Algebra 2 Lesson 5.6. Find the zeros of the function. With the warm-up today, I want you to find the zeros of this parabola. But first, maybe we need to review what the concept of finding the zeros is. You're looking for the number for x that makes the equation equal 0. So think about if there wasn't a y there and there was a 0. How could you find the number for x that makes the equation equal 0? Well, you have a lot of different techniques that you've learned in Algebra 1 and even earlier this year. What might come to mind first would be the quadratic formula. That will solve any quadratic equation 100% of the time. But we also know it takes a little bit of time to do that. You'll probably be using about half a sheet of paper showing each of your steps if you're being very detailed. So let's try to think of another way that might be a little bit easier. Is there another way to find the zeros of the parabola? Or I should say zeros of the equation. Another technique would be to factor the equation. You're looking for factors of 10 that sum to 7. And when you factor it into x plus 5 times x plus 2, because 5 times 2 is 10, and 5 plus 2 is 7, you would then set each of those individual factors equal to 0. What you've created is a multiplication problem whose product is 0. One of the factors is x plus 5, the other factor is x plus 2. And what you learned way back in 3rd grade, when you first learned your multiplication tables, is that when you have any multiplication problem whose product is 0, that means either the first factor is 0 or the second factor is 0. I'm not saying x is 0. I'm saying this entire factor, x plus 5, could have the value of 0, or the x plus 2 could have the value of 0. You'll then solve each of the little mini equations to learn that the zeros of this function, the zeros of this equation in number 1, are -2 and -5. The same process could be done with the next equation. But there is something else you could have tried. Instead of quadratic formula, instead of factoring, a very visual way, you could have graphed the equation. So using your calculator, when you graph the equation, you will see that this parabola crosses the x-axis at -5 and at -2. You've just instantly found the zeros of the parabola in a very visual way. Same things works with the next equation. You either could have factored it, or when you graph it, you see that it crosses the x-axis at -2 and at +6. So you've done this technique before. You've learned how to find zeros of the function, zeros of an equation. When you graph it, it's where the equation crosses the x-axis. But today's lesson is not going to be quadratics, where your biggest exponent is a 2. You'll have x to the 4th and x to the 3rd power. Can we use the quadratic formula on this equation? No, because it's not a quadratic. It has an x cubed. Do we know how to factor it? Not yet. But we could graph it using our graphing calculator. So after we plug this equation into the graphing part of our calculator, we will see that it crosses the x-axis in 3 places. Just like that exponent of 3 is telling you, you're looking for at most 3 answers. 1, 2, 3. Your graph crosses the x-axis in 3 places. 2 of them we see very easily, -1 and +3. The other one, we're not 100% sure exactly where that crosses the x-axis. And really, to be safe, after we've graphed this into our graphing calculator, we should look at the table. So if you hit second graph, you can look at the table for all of the integer ordered pairs. All the ordered pairs, I should say, when x is an integer. When x is -1, you'll see that y is 0. When x is 3, you'll see that y is 0. Any place in that table where the y is 0, the x value is one of the zeros of the function. So you clearly see 2 of them. Why don't we see this third one? Because it's not an integer. The x here is not an integer. It's something in between 1 and 2. So how do we find what that number is? Well, it's the whole reason we learned about synthetic substitution and synthetic division. We are going to take either of the 2 points that we first found, doesn't matter which you start with. I'm going to start with positive 3. I'm going to use synthetic division, using positive 3, and then using all of the coefficients of the equation of each term in descending order of the exponents. 2 is the coefficient of x squared, 2 is the coefficient of x cubed, negative 7 is the coefficient of x squared. There is no x term, so we have to fill in that space with a 0, and then there's the 9 that technically has an x to the 0. So these numbers, once again, represent the coefficients of each term when they are written in standard form, which means you're writing them in descending order of their exponents. And let's continue with our synthetic division. 2 plus 0 is 2. We next will take 2 times 3 to get 6. Add down that column, negative 1. Take 3 times negative 1, you'll get negative 3. Add down that column, you'll get negative 3. 3 times negative 3 gives you negative 9. When you add down that column, you get a 0. And that's very important with these problems. You should always be getting a 0. If you don't, it means you've done something wrong. Maybe it was a little arithmetic error, or maybe you just picked the wrong number. Maybe that's not a number that actually comes from the table. Maybe that wasn't the exact place where it crossed the x-axis. But you must have a 0 for a remainder. But remember, there was another place, another integer, where the graph crosses the x-axis, and that's at negative 1. So now, using our answers of the previous problem, the 2, the negative 1, and the negative 3, we will do synthetic division yet again. Pull the 2 down. 2 times negative 1 is negative 2. Fill it in up here. Add down this column to get negative 3. Negative 3 times negative 1 gives me 3. Add down this column, and again, we must get a 0 for our, in essence, what would be our remainder. These two numbers now represent coefficients of an equation that is equal to 0. Again, working it backwards, like what we learned when we learned our synthetic division in the previous lesson. We have a negative 3, and then we have our x term. Had there been more terms, we would have had an x squared and an x cubed. But we've worked it down this far with a remainder of 0, so that we have our remainder of 0 is equal to negative 3 plus 2x. Once we solve that little equation, add 3 to both sides, divide by 2, we've determined what that third 0 of the function is. It's at 3 halves. 1.5, if you want to write it that way, 1 1/2. So by doing this process, graphing it to find the nice, clean, clear-cut integers, and then doing synthetic division to find the non-integer answer, we have successfully found all 3 zeros of this function. Let's try one more. Here's a new equation. We don't know what any of these zeros are yet, so we're going to graph it first on our graphing calculator, and then look at the table. We see from the table that this graph goes through the order pair 2, 0, so 2 is a 0 of the function, and it goes through 4, 0. But we should have 3, because our biggest exponent is a 3. We should have 3 answers. The third one, we don't know exactly what it is, and we're not going to guess. We're going to use our process of synthetic substitution. We use the 2 first, pulling off each coefficient of each term, the negative 3 from the x cubed, the 20 from the x squared, the negative 36 from the x, and the 16 of the integer that technically has an x to the 0. We'll continue with our synthetic substitution process. Pull negative 3 down. Negative 3 times 2 is negative 6. Add down this column to get 14. 2 times 14 is 28. Add down this column, you get negative 8. Negative 8 times 2 is negative 16. Add down this column, you get a remainder of 0, which is exactly what you must have. Synthetic division one more time using the 4 with the answers you got from the previous problem. Pull the negative 3 down. Negative 3 times 4 is negative 12. Add down this column, 2. 2 times 4 is 8. And luckily again, we get another 0 for our remainder. So we're ready to write our equation. Again, working it backwards from right to left. 0 is equal to 2 plus negative 3x. Solve this little algebra problem, and we get our third 0 of the function. We now have all three answers. 2, 4, and 2/3. Those are the three places where the graph crosses the x-axis, and those are the three zeros of the function.